Good morning, students. Myself JP Sridhar, Assistant Professor, Department of Electrical Engineering, SJB Institute of Technology. Today I am going to explain the MATLAB programs related to medium transmission line as well as long transmission line. Now I will show how exactly we can execute the program by using MATLAB software. Okay, as we discussed the MATLAB software in 6th semester, you know how to open the MATLAB, how to save the program and how to execute the program, and basic the execution related things you know already. Just I will go to the program directly. So go to the desktop. I will double click on the MATLAB shortcut icon. So the window will be appeared like this. I am already opened the MATLAB. Just I will now you see, now the MATLAB window is appeared. Now I am already typing the program to save the time. Okay. So now coming to the medium transmission line, you know medium transmission line can be modeled in two categories. One is pi model and one is T model. In pi model, what will happen is the total shunt admittance is there, whatever is there, y, that has to be lumped equally into two sections, y by 2 into y by 2. Whereas in T model, the total impedance Z is divided into Z by 2 and Z by 2, and the total shunt admittance has to be connected at the center. Okay. Now I will show that. You see here, this is the ABCD parameters of medium transmission line. This is with respect to pi model. You see, we will have the sending end voltage Vs at left side, and we have the receiving end voltage at right side, and the load is connected at the load side, that is your receiving end voltage. And you see here, the total impedance Z is connected at the middle, and at the left and right side, okay, the total admittance is divided into two sections, that is y by 2 and y by 2, that is lumped equally, y as y by 2 and y by 2. Whereas in case of T network, the total impedance is divided into Z by 2 and Z by 2, and at the middle we have the admittance is connected at the center. So this is your T network as well as pi network. And if in MATLAB program we are explaining the pi network, once you know any one model, you can write the coding, MATLAB coding for other model equivalently by applying the ABCD parameters formula directly. Okay. So by understanding any one concept, you can easily write the program for other model also. Now I am showing the medium transmission line how to execute in MATLAB for pi network. Now I will show the program directly. See here. So to calculate the ABCD parameters, efficiency and regulation, what are the input parameters we required? We required impedance, we required admittance, and they are given VR and IR. They are given the receiving end parameters, that is receiving end voltage and receiving end current data is given. We have to calculate the sending end voltage and sending end current. We have to calculate. Along with that, we have to also calculate the efficiency and regulation, and also we have to verify the parameters, ABCD parameter, that is AD minus BC should be 1. Okay. As we know that already for medium transmission line, we derived the equation for ABCD parameters. Okay. So what is A? A is 1 plus y into Z by 2, and B is equal to Z, C is equal to y into 1 plus yz by 4, and D is equal to A. That is for medium transmission line, that to pi model. Okay. Once you remember the formulas and you know the input, you have to enter the given input. The given input is impedance, line shunt admittance, line voltage and line current. See here, they are given the line voltage. Okay. So what we have to do? We have to convert this line voltage into phase voltage. You know the formula how to convert the line voltage to phase voltage. Therefore, we have to convert this line voltage as VR, that is receiving end phase voltage as VL by square root of 3. And validation, you know that formula, x is equal to A into D minus B into C. This magnitude has to be 1. We have to verify this. Once you calculate the values of A, B and C, substitute in this, you will get the magnitude as 1 and the values are correct. So we know the ABCD parameters and we know the equations for sending end voltage and sending end current with respect to receiving end voltage and receiving end current is given by Vs is equal to A into VR plus B into IR. Similarly, Is is equal to C into VR plus D into IR. And we have to calculate the regulation. We know the regulation formula is given by sending end voltage minus receiving end voltage with respect to receiving end voltage. Okay. So in MATLAB, we are considering the positive value, that is magnitude. That's why we are considering the absolute value of Vs minus absolute value of Vr divided by absolute value of Vr into 100. So that is the formula for regulation. And once you calculate the regulation, you have to calculate the complex power with respect to sending end as well as receiving end. So we know in three-phase circuit how to calculate the complex power. Complex power is given by Vi conjugate. So the complex power with related to sending end is Vs. It is given by Vs into Is conjugate, and complex power with related to receiving end is given by Vr into Ir. And we know the efficiency formula in general. Efficiency is nothing but output by input. Here with respect to power we are calculating the efficiency, therefore receiving end power by sending end power multiplied by 100 will get the efficiency. This is the program with related to medium transmission line for given Vr and Ir. Similarly, if they are supposed to give Vs and Is, your ABCD parameter will going to change. Your ABCD parameter is going to change. This parameter will be changed. Okay, and your Vs and Is parameter is going to change that. And also for T network also ABCD parameter is going to change that. Okay, so once you remember the ABCD parameters and give the input as it is whatever the parameters and write the formulas for regulations, power and efficiency, you will get the required answer. Now I will execute the same program in MATLAB. Now I will save the already saved the program in MTL1. Okay, so I will save that, then I will run the code. Now it will ask the enter the line admittance. What is the line admittance? We have to enter the line impedance, that is Z. So what is Z? In the given problem Z is 19.75 plus J into 92.92. So that is your, sorry, it is entered in the editor window. We have to enter the data in the command window. Now I will enter that 19.75 plus J into 92.92. Now enter that. So because we are not putting the colon, we are not terminating that line. You see here, I will show in the program. See, so the line is not terminated. Therefore, whatever the value we are given here, same thing will be displayed in the command window. Now we have to enter the admittance. So admittance is given by 0 plus J into 0.001 is the admittance. Now here also line terminal is not terminated. So now the value will be displayed. Now enter the receiving end line voltage. Receiving end line voltage is 13.8 kilowatt. 13.8 kilowatt. Okay. So that is your 1,38,000 volts. So next we have to enter the receiving end current, that is 205.22 minus J into just a minute, J into 127.24 is the receiving end current. Now once you enter that, automatically it will calculate the remaining values. I will show that. You see, now I will take that command window. See, now Z value, Y value, we are entering the receiving end voltage, line voltage. Now receiving end current. Now it will calculate A, B, C, D, and it will be verify what is your phase voltage. Receiving end it is given here, and AD minus BC value should be 1, and Vs and Is is calculated. Now the regulation is 23, and complex power at sending end, complex power at receiving end, and the efficiency. Efficiency is 94% we are getting in medium transmission line. I hope you will understand the program. So for same network, for same pi model, they will give Vs and Is, and you have to calculate Vr and Ir and execute the same program, you will get the answers. I am not showing that, refer the manual, same procedure. Okay, just instead of Vs and Is, you calculate Vr and Ir. Ir is equal to A into Vs plus B into Is. Similarly, okay, Ir is equal to CVs plus D into Is. Okay, so that we have to calculate Vr and Ir. You have to calculate it here and execute. It is remaining ABCD parameter remains same for pi network. Okay, for T network it will be changed and execute that. Okay, so I hope you will understand. Thank you.